So as we look at the right angle trigonometry, the first thing you want to remember is the little SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. If I am asking for the trig function, I'm asking for the fraction. I'm not asking for an angle. I'm not asking for some other measurement. I'm asking for the ratio between the sides. All right, so for this first one, it's asking for sine. I am just asking you to list the opposite side over the hypotenuse side and then reduce if possible. So you have to first make sure you have the sides you need. It is always in reference to the angle that they have given you. So they are talking about this angle, so I am going to label that triangle. The hypotenuse is always the side that is opposite of your right angle. Then if you look at the angle you're talking about and walk across the triangle, that takes you to your opposite side. Opposite of that angle. The one that is touching the angle and is not the hypotenuse is the adjacent side. So I have the three sides labeled. Now I just need to put the opposite side over the hypotenuse side because I'm talking about sine. In this case, I don't have my hypotenuse, so I do need to use my Pythagorean theorem. Remember, it's a squared plus b squared equals c squared. A and b will always be your opposite and adjacent sides. C will be your hypotenuse. So I'm going to say 8 squared plus 15 squared should equal my hypotenuse squared, because I need my hypotenuse in order to solve this one. And then I'm just going to calculate that. So I'm going to say 8 squared, well, that is 64. 15 squared, that's 225. Add those two together. And then take the square root. So C is going to equal 17 here. So now I know my hypotenuse. If I want the sine of theta, which is what I'm solving for, the sine of theta, according to my little shortcut here, is the opposite side, which is 15, over the hypotenuse, which I just solved for, which is 17. The next one basically gives you the same thing, just without the picture, without the triangle, all right? So I am going to first see what did they give me. They gave me cotangent. So I'm going to label what I have. Remember, cotangent is going to be the reciprocal of tangent, all right? So my cotangent then is going to be adjacent over opposite. My secant is the opposite of my cosine, so that's going to be hypotenuse over adjacent. And my cosecant is going to be the reciprocal of my sine, so that's going to be hypotenuse over opposite. All right, so those are just the flips. So if I look at this, cotangent should be adjacent over opposite. That's the side links they've given me. They want me to find cosecant. Cosecant is the reciprocal of my sine. So that is going to be the hypotenuse over the opposite side. I know my opposite side, but I need my hypotenuse. Remember, my hypotenuse is my adjacent squared plus my opposite squared using Pythagorean theorem. So I'm going to say, well, to find my hypotenuse, I can say 12 squared plus 5 squared equals my hypotenuse squared. All right. And then I'm just going to simplify this. 144 plus 25, 169. So my C is 13. So now I know my hypotenuse and I know my opposite, and I'm just going to fill those in. The cosecant then is going to be hypotenuse that I just solved for over opposite that I already had from the beginning. So this is just, you're using your calculator. You want to make sure you're in degrees. The one thing I want to point out though is your calculator is only going to have sine, cosine, and tangent, all right? Above it, you will see sine -1, cosine -1, and tangent -1, but that means inverse. That means use those buttons when I'm solving for an angle. That does not mean the reciprocal of those. So if you are given something like cosecant, which was as a reciprocal of one of those three, then you're going to have to manually do that in your calculator, either doing 1 divided by the trig function, or you can get your answer and use your x to the -1 button on your calculator. All right, so I'm looking at cosecant, and I know that cosecant is the reciprocal of sine. So reciprocal is just 1 over, right? So 1 over my sine should equal my cosecant. All right, that's what reciprocal means. And so if I'm trying to figure out this value and I only have sine in my calculator, I'm going to say, well, cosecant of 70 should equal 1 divided by the sine of 70. And that's how you can do that in your calculator. You can do it that way, or you can do the sine, and remember that's going to parentheses, sine of 70, and then you can hit your, if you have a button like that, that will give you the reciprocal of your answer, right? But one of those two things will give you the cosecant of 70. And then it wants the nearest 10,000. That is 4 decimal places. 4 decimal places. In your calculator, you're going to get 1.06417, and it's going to keep going, right? If I want the nearest 10,000, I'm going to say this is tenths, hundredths, thousandths, 10,000. This is the one that I'm rounding, but I look at this one to decide what to do with it. If it is 5 or above, then I'm going to round that guy up. It is 4 or below, I'm going to keep it the same. If this was a 9 and I rounded up, I would go one more place over and round up with a 0 at the end, okay? So there's a little tricks to them, but make sure you know you're rounding because those are easy errors and we don't want to miss those easy errors. All right, it says find the measure of the indicated angle to the nearest degree. That means whole degree. You should not have any decimals on this answer because it says to the nearest degree. This is where you're going to use your inverse functions on your calculator. So what I do is I look at this question mark and I label my triangle based on that angle. Remember, hypotenuse is always the one that is over opposite of my right triangle, my right angle. Then the one opposite of the angle I'm talking about is my opposite side. And the 16 then would be my adjacent side. So then I look and say, what sides did they give me? There's no need to use the Pythagorean theorem here. I just use the sides it gave me. It gave me adjacent and hypotenuse. Going back to SOHCAHTOA, which of those 3 trig functions uses adjacent and hypotenuse? The cosine, adjacent, hypotenuse. So I know that the cosine of this angle that I'm trying to find should equal the adjacent side divided by the hypotenuse side. Remember, when you're solving for the angle in your calculator, you're going to use the shift button. So you're going to say second or shift. Then you're going to use the function you need because that's going to give you the inverse function. And it will open your parentheses and you can just do your division. 16 divided by 52. Right? And it wants it rounded to the nearest angle. So no decimals here. You should get 72 degrees. So for solving a triangle, you should have all of the angles identified and all of the sides identified. So angle A, angle B, and angle C. Obviously, that guy is going to be 90 degrees. Then we have side length A, which is the side opposite of my angle A. Side length B, we don't know. And side length C is 10.7. Anytime you have 2 of the 3, that's probably going to be the easiest one to solve for. If you have 2 of 3 angles, then they should all add up to 180. If you have 2 of 3 sides, you can use Pythagorean theorem, okay? So I have my a and my c. I can use Pythagorean theorem to solve for b. A squared plus b squared, which I don't know, should equal c squared, right? And so we're going to do our Pythagorean theorem and solve back for our b and have all of my sides accounted for. You can round to the nearest 10th inside of it if you want to. You may get a little bit off when you do that, but that's okay. As long as you show me your work, you're fine. So solve back to get your b squared, and then we're going to take the square root. So b is approximately to the nearest 10th, 9.2. All right, so we have a, b, and c. All right, here's the thing. I am now solving for an angle. So I'm going to start with angle A. And I have the opposite side. I'll use the 2 sides it gave me. And I have the hypotenuse side. So just like in the problem above it, I'm trying to solve for the angle. The angle. Opposite and hypotenuse. Which of my 3 SOHCAHTOA deals with opposite hypotenuse? Yeah, the sine. So the sine of A should equal the opposite side over the hypotenuse side. Remember, when you're solving for your angle, you use the inverse functions on your calculator. So I'm going to say, well, I'm going to use the inverse function of sine to solve for my angle. All right, and so this, anytime you're solving for an angle, you're going to do that inverse sine or inverse tangent or inverse cosine, whichever one. All right, and again, we're rounding to the nearest 10th for all of these. So you should get that A is approximately 30.3 degrees. And so once again, when you have 2 of the 3, you don't have to use trig, because you can just say, well, I have 90 degrees and then I have 30.3. So I can just, those should all add up to 180. So I can say, well, 90 minus that 30.3 degrees should give me my angle B. And it does. 90 minus 30.3 degrees will give you angle B of 59.7 degrees. So you don't even have to do your trig function. You could if you wanted to. You could use cosine there and find it, but you don't have to. You can just subtract from 90. So remember, negative just means going the opposite direction. So positive angles go counterclockwise, negative angles go clockwise, all right? And so if I'm going clockwise to negative 150, this is going to be negative 90. This would actually be negative 180. So I know I'm somewhere before negative 180. Specifically, I'm about 30 degrees before I stop. So I'm going to stop at about 30 degrees before there. And that should be negative 150 degrees. All right. For 665, I am going counterclockwise because it's positive. But it goes past a full circle, okay? So I'm going to say, well, I know I need to go a full circle. And what does that leave me? Well, 665 subtracting that circle that I've already got there, right, is 305 degrees. So it's a pretty big loop even after that one. And so I know that I'm going to go another 90 degrees, another 180, another 270, right? But then I only need to go about 35 degrees past that 270, right? And so that's where my angle is going to end up, is right there. So I went a full circle, which left me with 305 degrees. And then I went another 305 degrees from that. And remember, each of these is 90. So 90, 180, 270, 360. And so I knew I went just a little past the 270 piece of it. A positive and a negative coterminal angle, all right? I'm just going to take the negative 150 degrees and I'm going to add a full circle. That's going to give me my positive coterminal angle. And then I'm going to take the negative 150 and I'm going to subtract a full circle. And that will give me my negative coterminal angle. So reference angles are to the closest x-axis, whichever side you're on. So if you're in the first or fourth quadrant, it's how far away from this x-axis we are. If you are in the second or third quadrant, you're seeing how far away from that side of the x-axis you are. They've told me that I'm at 660. So my closest x-axis would take me over here. If you need to subtract, you can see that they went a full circle. That's fine. And so this would be the same as 300 degrees. Remember, a full circle around. 300 degrees would also land here. So how far away from this? Well, I'm going to be 360 is where I'm going to end up. So I'm 60 degrees away. So my reference angle for this is 60 degrees. Reference angles are always positive. So it doesn't matter if your angle that they gave you was negative, your reference angles are always positive. Always positive. All right, this was leading up to the unit circle. So unit circle, those would only be at most one away from the center, right? But this is any point on the circle. We're going to find the trig function that it wants. And so for these, you can think of a little bit differently. Sine of your angles, that's going to be your y value over your r. Cosine is going to be your x value over your r. And tangent is going to be your y value over your x value. All right? So we start moving towards the unit circle with this. Our r on our unit circle is always 1. But this is not going to be an r of 1. We actually have to solve for it. If they ask for, I'm going to jump to tangent first. If they ask for tangent, I don't need to solve for r. Some of you on your quiz solve for r. That's not necessary for tangent. You only need your x and y values for tangent. And so they've given you everything you need to give me the tangent here. My tangent is going to be my y value over my x value. They gave that to me. Y value, x value. That is my tangent, negative 15 over 7. I don't have to do any solving there for tangent or cotangent, okay? For sine or cosecant, cosine and secant, I do need to solve for my r because I do need my r value. So for this one, I will need to solve for it. So I'm going to say, to find my r squared, I need my x squared plus my y squared. So to solve for this, I'm going to say 18 squared plus 12 squared. And then I will solve for r using the square root. All right, 468, and I don't think it has a perfect root. So 468 doesn't have a perfect root, so we're going to just, I actually think it's going to do. All right, so you can use your factor tree here. Anytime it's an even number, start with 1. So you're going to be able to pull out a 2 and a 3. So r is going to equal a 6 comes out, a 13 stays in. All right, so I have my x, I have my y, and I have my r. For cosine, If you'll go back to here, cosine is x over r. All right, so my x value was 18. My r value was 6 square root of 13. All right, I do need to reduce it. 6 goes into both of those, so I can cancel the 6 here, and that's a 3. So that gives me 3 over the square root of 13. And then I do need to get that radical out of the denominator. All right, so that's going to give me 3 square root of 13 on the top and just 13 on the bottom. Had I been in a different quadrant and one of those had been negative, I would have a negative there. So pay attention to your positives and negatives for these. But that's going to be your answer. Degrees to radians and radians to degrees. Those are fairly simple. If your pi is on top, it's going to be on the bottom when you convert. So this is radians. I'm going to convert with 180 over pi. Your pi's will cancel. And then anything that can go into these will cancel. So I'm going to look at the 12 and the 18, or 180 rather, and see if something goes into both of those. If you don't see that 12 can go into it, you can start smaller. But if you look, 12 goes into it one time with 6 left over, and then 12 goes into 65 times. And so it's going to go in nicely. And then I'm just going to multiply across 11 times 15, 165, and I am now in degrees. If I needed to go the opposite direction, degrees to radians, I'm going to multiply by pi over 180 degrees. Here my degrees will cancel. I can reduce. I can reduce the 0 out, and then both of these are also divisible by 3. And so I can say, well, that's going to be 5 pi over 6. For arc length, it has to be in radians, so I have to take that 240 and do just what I did above, multiply by pi over 180. And then I also have to multiply by my radius, which is 10. So I do want to simplify this as much as possible. The zeros simplify out, and then you can see that 6 will go into both of these. So 6 into 24, 6 into 18. And then you do want to simplify by multiplying across. Some of y'all left it with like the 4 times the pi times the 10, but you need to actually multiply across. 4 times pi times 10 is 40 pi. And in the denominator, I just have that 3 left. And so that is the length of my arc. And you can leave pi in your answer. That's what leave an exact value means. So it's possible you're going to have one like this, that 315 is on the unit circle, but negative 315 is not. And so you have to think about where it would be. All right, so negative is going to take me this way, 90, 270, or 90, 180, 270, 315 actually is going to drop you off here. And so 315 is going to be a 45-degree angle in the first quadrant, all right? Every 45-degree angle has the same sine and cosine. Just depends on where you are. So on the unit circle, your 45 over here is going to be square root of 2 over 2 for x value, square root of 2 over 2 for y value, all right? Tangent, remember, is y over x. So I'm just going to do y over x. Anything over itself is just 1. And so these are going to somehow give you an angle on the unit circle, whether it's one that's directly on the unit circle, and I want you to give me the value, or whether it's one that's not directly on the unit circle, and I want you to use how it drops you off at 1, like this one. But like for 57, 7 pi over 6 is on the unit circle. And so you can just give me the tangent of 7 pi over 6, y over x, keep, change, flip, right? And so sometimes it's going to be one that's right on the unit circle, and I just want the value. Remember, sine on the unit circle, my r is now a 1, so I don't even have to think about my 1 or my r. So my sine value on the unit circle is just the y value. My cosine is just the x value. And my tangent is just y over x. All right? So if I ask for the sine, I need you to look at that unit circle and say, oh, the y value there, that's the sine. All right? So you don't have to calculate it if you know your unit circle. For graphing, for sine or cosine, your amplitude is the absolute value of your A. Your period is going to be 2 pi over your B. And technically that's absolute value, but your B on these are always going to be positive for me. Your vertical shift, that one's easy. That is just your D value. And your phase shift is going to be negative C over B. So remember your A, that is the number in front of your trig function. Your B is the number in front of your variable or your theta. Your C is the number being added or subtracted inside the parentheses. And your D is your number being added or subtracted outside of your parentheses. Most of you did fine on those 4 pieces. The only problem I saw is when you reduced your fraction. So I'm going to show you one that has like a whole number and one that doesn't. So for this one, the amplitude is going to be 1/2. The period is going to be 2 pi over 3. The phase shift, all right? This is where some of y'all struggled a little bit, all right? The phase shift is going to be 2 pi over 3 over my B, which is 3. All right? Anytime you have a fraction over a whole number, you do keep change flip, 2 pi over 3, but you flip that 3 to be 1/3. You can also think of it as you're always going to multiply these denominators. It's going to be 2 pi over 9. 2 pi over 9 there. And so some of you did that incorrectly. You flipped and multiplied by 3 instead of dividing by 3. Lots of you did that same thing. And then your vertical shift is very simple. It's just going to be a positive 1. All right? Vertical shift, that tells you where your midline is. Your dotted line should go up positive 1. Your amplitude goes up and down from there. So from 1, I'm going to go up 1/2. That's my high point. From 1, I'm going to go down 1/2. That's my low point. My phase shift, because it's negative C over B, is actually going to go left. 2/9 is a pretty small shift, so I'm just going to estimate that I'm about right here. All right? My period was 2 pi over 3. So the easiest thing to do this is to say 0, where would 2 pi over 3 be? That's 2/3 pi. And so 2/3 pi is going to be somewhere in here. And you can get it to common denominators if you want to. Like 2/3 is going to be 4 pi over 12. And then this is going to be 9 pi over 12. So you can just figure out where it's going to be. So it should be normally about right here, but I shifted it over. So about right here is going to be my ending point. And then what does my sine graph look like? Remember, my sine graph starts at the middle, goes up to the high, back to the middle, down to the low, and back to the middle, right? And so I just need to do that with my different pieces. Cut it in half, cut it in fourths, and then you're going to start at your middle, go up to your high, down to your middle, down to your low, and back to your middle. So this is going to be a little tiny graph here. We do the same thing with the sine or the cosine graph. The amplitude, that's the number in front, my A. My period, that's 2 pi over B. B here is 1/2. All right, 1/2. All right, so we do keep change flip. 2 pi divided by 1/2 is 2 pi times 2. So my period here is 4 pi. My phase shift is negative pi over 2 over, this is again 1/2. All right, over 1/2. And so my phase shift is actually negative pi. And then vertical is negative 2. So I'm going to go to my vertical. That's down here. My amplitude is from that point. 1, 2, 3 up. That's my high. 1, 2, 3 down. That's my low. Phase shift shifted me an entire pi over. All right, so there's two ways to do this particular one. I'm not going to give you one that goes completely off the graph like this one. Negative pi is actually over here. You can think of it two ways. Normally, you would end at 4 pi because that's your period. So you're going to end at 3 pi if we shift it over. But again, I'm not going to give you one that goes off the graph. So we'll just know that I'm not going to give you one that does that completely off the graph. I just wanted to show you what it looks like. But I'm going to draw it off the graph here just for now. So negative pi is where I start. I go 4 pi from there. So this is 1 pi, 2 pi, 3 pi, 4 pi. That's my ending. This is my halfway. This is my 1/4. This is my ending. Remember, for your cosine, you start at your high, you go to your middle, then you go to your low, back to your middle, and up to your high. That's what that standard one looks like. So if I start at my high, remember this is my middle, my high then is right here. I go to my middle, I go down to my low, back to my middle, and back up to my high. So that one's going to look something like that.